Because when you take a curve like this and rotate it about the x-axis, then you pick up something like this, and you basically make a slice. You make a slice here, and when you make a slice, what do you pick up? From the if you look at it, you look at this thing from the side, it looks like what? Huh? When you rotate this thing about the x-axis, it looks like what?
Which side are we looking at? That
If you
side?
look at it from the side,
Oh, that side of the circle.
it looks like a circle. So basically what you pick up is discs. Pi r squared delta x. Pi r squared delta x, and r will just be your function. So we'll pi f squared delta x integrated. But you are using the geometry of a circle. When you take a slice here, you say to yourself, well, what is the thing you see when you slice? You see a disk. You say you take the radius squared, multiply by the thickness. Of course, the radius is changing as you move along. And add them all up. Take the radius squared, multiply by pi, and by the way, the radius is changing. Take your radius, multiply by square root, multiply by pi, multiply by the thickness, and add them all up. Now what happens if you take the thing and you slice it and you see something else? Like a square. That's supposed to be a rendition of an okra.
Oh, what?
The thing they eat in Louisiana. Take an okra. Okra looks like this. If you look at it from the side. Okra looks like that. When you slice it, you don't see a circle. You ever slice a piece of okra?
Yes.
It's not a circle, is it?
No. It's almost like kind of like honeycomb. Like,
It looks like kind of like a square.
yeah. But it's got holes on the inside.
So your farmers in Louisiana would like to know what is the volume of the okra. Right? You can do that. That's the way the engineers do it. They don't do math, huh?
It's just easier.
So, what you have is a curve. Oh, gosh. So it's a strange shape that you see every time you slice it. Okay.
Okay, you're telling me.
So what you have is you have some strange function. And every time you slice it, you're going to pick some strange looking object that has a thickness. What is the volume of that? You'll take the area and multiply by the thickness. So this will be the area, and this will be delta x. So every time you slice it, you see an area. Every time you slice it, you see an area. I don't know what the face is. Maybe a square. Maybe a square.
I just got hurt.
This is my, that's my best okra. Okay. Okay? You slice it, and you see a square. You slice it, and you see a square. You slice it, and you see a square. You see, what's the area of that square multiplied by the thickness? You get a volume. What's the area of that square multiplied by the thickness? You get a volume. So you take the area of the face, multiply by the thickness, and add them all up, and let delta x go to 0, keeping in mind that the area is a function of x. This is called the general volume form. I'm sorry, that's a definite integral. I'm sorry? Now on these problems, you will have to determine what is the area of the volume. In other words, you're going to look for two things. You're going to look for the shape. The slice. What is the shape of your slice? Here I'm saying, oh, I don't know what that shape is. That's a peanut. But it may be a square. It may be a triangle. Right? Toblerone chocolate. You take your Toblerone chocolate. Every time you slice, you look at it from the side, you see a triangle. But the envelope is weird. It's a non-linear envelope. Every time you slice it, you see a triangle. So every time you slice it, you see a triangle. You need to find the area of that triangle depending on where you are. This is your x, your area is quite big. This is your x, right here. The area is a little smaller. But you will have to determine the dimensions of your triangle based on where you are. So you have a shape, and then you also need the dimensions depending on where you are. In other words, what is telling you how big your face is going to be? So when you read these problems, you have to ask yourself, what are these two things? What is the shape? And what is telling me how fast the thing is changing? What kind of ochre do I have? Is it that kind of ochre? Or is it that kind of ochre? Or is it this kind of ochre? Must look out for the shape. Is it a circle when you slice it? Is it a square when you slice it? Is it a triangle when you slice it? Is it a semicircle when you slice it? Read the question. And then it will tell you how the dimensions of that thing is changing. When you do y equals 1 over x, you're looking for the radius. How is the radius changing? It's a function. Let's do an example. So here we have it. The volume of the described solid. The solid lies between planes perpendicular to the x-axis. These are the planes. Perpendicular to the x-axis. That is when you look at it from the side. What do you see? Squares. And then you want to know how fast is the dimensions of the square changing. Is it decreasing by 1 over x? Increasing quadratically? Increasing linearly? If it's increasing linearly, you're picking up a pyramid. If it's increasing quadratically, who knows? But they tell us. The bases, these are squares, whose bases run from the parabola y equals negative 6 square root x to the parabola y equals 6 square root x. So that's how the squares are changing. So we're going to need this formula. X equals 0 to x equals 7. We're going to integrate from 0 to 7 the area as a function of x, delta x. I need to know, what is this? Well, I know that I have squares.